arrhenius and bronsted lowry acids and bases.
Arrhenius defines an acid as a hydrogen-containing compound that ionizes to yield hydrogen in aqueous solutions. He defines a base as yielding hydroxide.
Bronsted defines an acid as a hydrogen ion donor and a base as a hydrogen ion receptor.
These are the three types of definitions for acids and bases: Lewis, bronsted, and arrhenius. As you can see in this picture, arrhenius bases are also surrounded by a bronsted, which means any arrhenius base is a bronsted base and a Lewis base. Similarly, if a bronsted acid or base, it is also considered a Lewis acid or base. These are two equations that show how an arrhenius base can also be a bronsted. In the first one you see hydroxide, and in the second one you see hydrogen, which shows that they are both arrhenius bases. As proven before, that means that it is also a bronsted. So these two equations are both arrhenius bases and acids and bronsted acids and bases. It's like a square and a rectangle. Arrhenius is a square, and bronsted is a rectangle. A square is always a rectangle, but a rectangle is not always a square. So an arrhenius acid and base is always a bronsted acid and base, but a bronsted acid and base is not necessarily an arrhenius acid and base. Like in these two equations. In the first one, there is no hydrogen, which shows that it cannot be an arrhenius acid. And in the second one, you might see the hydroxide ion, which would say that it's an arrhenius base. But it's not, because there is no hydroxide ion in the original equation. Is any arrhenius base also a bronsted base? Of course. Yes, it is.
This was created by Paige, Jonas, and Manuel.